Welcome to AI Podcasts. I'm Ethan.
And I'm Maya. Today we're looking at a neat AAAI 2025 demo paper called Data Wrangling Task Automation Using Code Generating LLMs. What's the headline, Ethan?
TLDR, they show that instead of asking an LLM to fix every row in a table one by one, you can have the LLM write a small piece of Python once, then run that code across the whole dataset. You keep accuracy about the same or better, and you slash the number of model calls from, say, thousands to a few dozen.
So it's like getting the chef to write a recipe instead of taste testing every plate?
Exactly. Learn once, run many.
Who's behind it?
Two names to remember: Ashlesha Akella and Krishnasuri Narayanam from IBM Research. The demo appears at AAAI 2025, and there's a longer follow-on called CodeGen Wrangler in the NACL 2025 industry track.
Got it. Let's set the stage. What problem are they tackling?
Data wrangling. Think missing values, catching typos, and fixing inconsistent entries in big tables. Traditional statistical tools are fast but miss semantic context, like realizing the state should match the city. Deep learning methods can learn that nuance but need training for each dataset. Early LLM approaches did something clever: prompt the model row by row, but that gets slow and expensive as your table grows.
Right, because the model has to think every single time, so what's their big idea?
Treat the LLM like a programmer. Feed it a small representative slice of the data and the task description, and ask it to generate executable code that captures the pattern. Once the code looks good, you run it locally over every row. The LLM steps out of the hot path.
Nice in theory, but real data is messy. How do they make the prompts small enough and the code robust enough?
A few tricks. First, they pick only the columns that matter for the target column using a lightweight model, so the prompt isn't bloated. Second, they split tasks into two routes. If the task needs outside knowledge, like mapping a city to a state, they pull in a small reference table and prompt with it. They call those memory-dependent tasks. If the table itself has enough signal, say opening and closing times imply 24-hour service, that's memory independent.
And the code it generates, how do they know it's any good?
They iterate. The system asks the LLM for code, tests it on held-out rows, then folds the best snippet back into the next prompt, like showing your previous draft in a code review. It also generates multiple snippets and takes a majority vote over their outputs, which helps with stability.
So it's not just a single shot, it's a loop that keeps sharpening the rule.
Exactly. And for the code model, they report using a Granite code-oriented model. The point isn't the brand, though. It's the pattern. Sample a little data, synthesize code, validate, improve, then execute at scale.
What did they test this on?
In the AAAI demo, two public tabular datasets, an airline dataset and a big basket product dataset. The tasks were missing value imputation, error detection, and error correction.
And results?
The code generation pipeline matched or slightly beat the row-by-row LLM on accuracy while cutting calls dramatically. For example, one task went from roughly 1,300 calls to about 20. That's the cost and latency win.
That's a big drop, but does it hold beyond two datasets?
The extended study, CodeGen Wrangler, looks across a dozen datasets. The pattern holds. When you can express the logic cleanly, generating code trims the number of calls by roughly an order of magnitude. It also shows where the method shines and where it struggles.
Let's dig into the why it works part. What makes this recipe approach strong?
Many wrangling tasks are governed by stable rules. If opening and closing times are both midnight, a store probably runs 24 hours. If a country code must match a continent code, there's a small mapping table you can consult. Once the LLM turns that into code, you get fast, repeatable decisions without rethinking each row.
And the rough edges?
Error detection, when wrong can mean subtle spelling issues, inconsistent categories, or context that isn't cleanly rule-like, a short piece of code won't capture every nuance. The extended paper notes that for highly semantic or fuzzy patterns, performance can be mixed. Also, for tricky tasks, the prompt refinement loop can take many iterations to converge.
So if the problem is crisp and logical, code wins. If it's vibes heavy, not so much.
Exactly.
Let's talk evaluation choices for a second. Any gotchas we should keep in mind?
A couple. The AAAI demo uses 2 datasets, which is fine for a demo, but not the last word. The international paper broadens to 12 datasets, which helps. Still, I'd love to see head-to-head comparisons against other code-gen wrangling systems under the same retrieval and execution setup. And, whenever you execute generated code in production, you need guardrails, sandboxing, resource limits, and small unit tests to catch bad logic.
Good point. Generated code is fast and cheap to run, but you want safety nets. How about the system design choices? Anything listeners should remember?
3 memorable bits. 1, column selection keeps prompts focused. 2, retrieval brings in small reference tables when the model's internal knowledge isn't enough. 3, iterative prompting with a best so far code snippet nudges the model toward better rules. Together, they make the approach practical.
Can we make this concrete with an example?
Sure. Imagine a table of airports. You need to fill the continent code. The system samples a few rows, includes a mini table that maps countries to continents, and asks the LLM to write a function. The function looks up the country, returns the matching continent code, and says unknown if there's no match. After a couple of iterations, that function generalizes well, and you run it across the whole dataset without more LLM calls.
That's straightforward. And a trickier one?
Product categories from freeform names. Now you're parsing ambiguous text like classic tea and midnight blue. A short rule might help for obvious patterns, but it won't cover every brand or naming quirk. That's where accuracy can wobble, and you might need richer models or a human-in-the-loop review.
Right. So where does this line of work go next?
Standardized benchmarks with noisy real business data would be great. I'd also test how well these learned rules hold up over time, say when schemas drift. On the engineering side, invest in testing harnesses for generated code and clear explanations that show which rule or lookup produced a given fix. And I'd explore combining code generation with selective row-level calls only for uncertain cases.
Like escalate only when the recipe isn't confident.
Exactly. Keep the recipe for the 80% and call the chef for the edge cases.
Before we wrap, give me the coffee break takeaway.
If your data cleaning task mostly follows stable rules, ask the LLM to write the rules as code and then execute that code at scale. You keep quality competitive with per-row prompting, but you save a ton of inference time and cost. Just add guardrails and be honest about tasks that need deeper semantics.
Practical, cost-aware, and pretty elegant. That's data wrangling task automation using code-generating LLMs.
This is AI Podcast. I'm Ethan.
I'm Maya. Thanks for listening, and we'll see you next time.